Okay, so now we're going to just go over a few more keywords just to make sure we get the lay of the land. Okay. In object-oriented programming, there's also this concept of inheritance, where one blueprint can build off of another blueprint. In this case, our blueprint robot is going to build off of another blueprint, which would be what? Timed robot. This word extends means, hey, go to timed robot, start with that blueprint, and then add my stuff on top of it. And you can do that in Java. Some languages like C++ have what's called multiple inheritance, where you can say, hey, I want all of these blueprints to be part of my blueprint. There's advantages to that. There's also disadvantages because now you're having to keep up with 5 different blueprints, right? So when you see the word extends, that just means take this other blueprint, add on to it. Any questions about that word? Okay. Override. If you ever see @override, that means, hey, I'm going to take something from one of the other blueprints and I'm going to redefine it. So even though timed robot, let's say this is called robot init. If I go to timed robot and I look for robot init, that's not here. So I go to, actually here, we'll do it. We'll do it here. We'll right click on robot init, go to definition. It's in here. So it won't take me any further. But there's this thing called robot init, and let's see if I can go to definition here. Yeah. It's in this other class called iterative robot base, which is actually, is it a class? Let's find out. Iterative robot base is a class. Okay, so it's still a class. But it's defined in there. But I'm saying override. So I'm saying is, hey, ignore what iterative robot base calls robot init. Ignore what timed robot calls init, or robot init. I'm telling you this is what it does. So all of these things that say override are in somebody else's blueprint, and we're going to redefine what they do. In some cases, they're not going to do anything. We don't want them to do anything. In some cases, they will do something. Any questions on that? Okay, we'll probably see more of that later. Okay, another keyword you'll see here is public. Public means I want other parts of the code to be able to use this. So in this case, I've got robot init. I want some other part of the code to be able to use robot init, and so it's public. By default, a lot of things are going to be public. Some things will not be public. They will be, opposite of public is private. And private just means I don't want anything outside of this class to be able to use this. It's a way to keep it secret and to give you a little bit more control over what you're doing. That doesn't mean nothing can see it, because there is no like hidden stuff, right? It just means, hey, I don't want whoever's using this class to be able to do this directly. It gives you a little bit more control over how they use it. Okay, any questions on those words? Okay, yeah.
Why would you want to control how other people are using it?
It's a good question. So let's look at an example. Kinda. That's not too far off. So let's say I've got in here, I've got a class called car. And in car can do a lot of things, but one thing car can do is drive, right? And inside drive, it'll do some stuff. And maybe I say, you know what, it's really complicated to drive. I want to break that out and make it a little bit easier. So maybe I break that out and I say, you know what, I'm going to actually have a steer, and I'm going to have a gas, and I'm going to have a brake, and I'm going to have a shift so I can change gears, right? Maybe I break that out into all these other things, and I put all of them inside of here as a way of making the code easier for me to write. But I don't want somebody who's using my car object to be able to steer, gas, brake, and shift. I want them to be able to drive. So I would make drive public, but I would make all these private so that I can have a little bit more control over what they can do, but I can also make it easier for me to write and expand out my code. It's a way of controlling the interface, controlling what they're allowed to see and what they're allowed to do. Because we do want them to be able to gas, but we don't want them to only be able to gas. We want them to gas when they're driving. Does that make sense? Okay. So that's the idea of, why sometimes you'd want it public, sometimes you'd want it private. There's advantages and disadvantages. Okay. So the next thing, the next idea we need to have, we talked about the blueprint as defining two things. It defines what the objects will be able to know, what their data is, as well as what they'll be able to do. So a car can drive, and then the code defines how you drive, right? So when you want to talk about what the class or what the object can do, there's a certain thing you can use. I know some of you have been working through the programming thing on Code.hs, so you might already know the answer to this. But what is the thing in a Java program that lets something do something? It is either called a function, or, and in Java you'll hear it called this probably more often, it is called a method. So these are the two words you'll hear, method and function. And generally it's called a function. Specifically in Java, we're going to call it a method. But either one works. These are programming ideas, right? Where you're going to put some code that can be run over and over and over. So for example, if I wanted to drive the car at a certain speed, I'm going to define a function. That function is going to have a name. What's a good name for that function? If it's going to drive, I would call it drive. The names of your functions, the names of your methods are verbs, right? It's what does the thing do? Because the methods are the actions. The functions are the actions. Okay? Then you've got this open and closed parenthesis. And then you've got a curly brace. And then you've got another curly brace. This is a function. This is a method. Now inside of here, you put lines of code to do stuff. The curly brace just says, hey, where does it start and where does it stop? And then the weirdest part of this, and I think a lot of people get hung up on this early on, what's with the parentheses? Why are there parentheses here? It's because with functions and methods, you can also give them data. So this is a function called drive. Is it taking any data? No, there's nothing there. But I have to put the parentheses there, otherwise it's hard to say that it's a function. But I could also say, oh, I actually want to drive at a speed. And now I've got a function with a name drive. Here's the body, start and end. And now it's taking an input. So you can take inputs into functions, inputs into methods. So when you look at the robot file, all of these are functions. All of these are methods. These are all things the robot can do. Any questions on functions and methods right now? And now, how can we tell these are functions? How can we tell these are methods? Like, what's the giveaway? What are some of the things we look for to know, hey, these are functions?
Void.
Void is a good indicator. We'll talk about what void is in a minute, but not all functions have void.
Well, it has the curly braces.
It has the curly braces. Now, Curly braces are not enough to be a function because the class also has curly braces.
Right. And it also has the name, which is highlighted in yellow, which is
It's got a name in this specific color, but it's also got one other thing.
well, it has the
Those parentheses. Anytime you see parentheses like this, it's probably a function. There are times where you're not using parentheses though. There are times when parentheses mean other things. But at this level, these are functions. And we'll see sometimes where the parentheses don't necessarily mean it's a function, but these are all functions. Now, there is a key word here I do want to talk about now that we've talked about functions, is void. What does void mean? Well, let's take a look back here and see if we can draw any ideas. What does this part of the function represent? Well, sorry, this part is what you're doing. What is this? I think you said it. This is input data. Anything inside those parentheses is an input to the function.
Like this has to be happening in order for this to run.
We need this piece of data. For example, like if I'm driving, I could drive at 0 speed, I could drive at 10 miles an hour, I could drive at 100 miles an hour. There's a variable there, but no matter how fast I'm going, driving still works about the same. I just changed the number. So that is the input to the function. Now, if we look at all of these functions, none of these functions have inputs, and that's okay. You can have no input. But this doesn't have anything to do with the input. This has to do with
Not having input.
not quite, but it's related. What's the opposite of input?
Output.
Output. Void has something to do with the output. Because not only can a function take data in, a function can give data out. For example, if I were to write a function called add, and it would be number 1 and number 2, is that going to give me some data back? I would hope so, right? It should give me number 1 plus number 2, right? A void function can't do that. A void function does not have output. It does not have information it gives back to you. It is a function that just does something, and that's all it does. It does it, and it's over. And so all of these functions are void functions because they don't give you information back. They just do something. And what they do is all specific. We will look later, I don't know how later, at not void functions. But for now, most of the functions we're going to look at are going to be of the structure where you've got a function name, you've got no input, it's void, and then you're going to do stuff inside the function. Now notice, public is not part of it being a function, right? If I were to highlight this, all of this that's highlighted, that's what makes it a function. What does public do?
It is who you're sharing it with.
So you can share it outside of the class so that other parts of your code can use the robot init method. And override's not part of the function. It's telling you what?
That you're changing code from this.
That you're saying, hey, I know I'm using somebody else's blueprint for this part. Ignore what they said. Do what I'm saying. So that's the key there. Before we start looking at what these functions are there any questions?